Hi, Assalamualaikum and good day. Today you are going to learn the next technique of integration, that is integration of trigonometric substitution. This is the objective of today's lesson. By the end of this session, you should be able to solve integration using trigonometric substitution. Trigonometric substitution is used to simplify certain integrals containing radical expression. The goal of trigonometric substitution is to replace the square roots or rational power of quadratic expression which may not be simply evaluated using other method of integration. If the integral contain expression of the form of the square root of a square minus x square or the square root of x square plus a square or the square root of x square minus a square in which a is a positive constant, the following substitution may apply. There are three trigonometric substitutions that can be used depending on the expression inside the square root, such as x equal to a sine theta, x equal to a tangent theta, and x equal to a secant theta. Make sure you use the correct derivative of each substitution, otherwise you cannot get the correct solution. Before you apply the method of trigonometric substitution, first you need to choose the correct trigonometric substitution for the given integral and let it equal to x. Then differentiate the x and substitute both x and its derivative into the given integral. Simplify, you will get a new integral in terms of theta only. Hence, integrate as usual by applying the following 5 steps. Number 1, substitute. Number 2, expand. Number 3, factorize. Number 4, apply identity. And number 5, simplify. Refer to example 11a. As the expression inside the square root is a square plus x square, we should apply the trigonometric substitution x equal to a tangent theta. Here a square is equal to 5. Therefore, a is square root 5. Differentiate x equal to square root 5 tangent theta. The answer is equal to square root 5 secant square theta. Substitute both x and its derivative into the given integral. Simplify, you'll get a new integral in terms of theta only. Next, expand the expression with the power and factorize the expression inside the square root. Square root 5 tangent theta to the power of 2 can be simplified to 5 tangent square theta. Factorize the 5 inside the square root, you should get 1 plus tangent square theta. 1 plus tangent square theta can be written as secant square theta using identity. Simplify the integral, you should get 5 the integration of tangent square theta secant theta d theta. To solve the integration of product of trigonometric function, refer back to the technique that you have learned in the previous lesson. By replacing tangent square theta with the relevant identity, that is secant square theta minus 1, and expand, you should get 5 integrate secant cube theta minus secant theta d theta. By using the formula of secant theta to the power of n, integrate one by one, you should get the following answer. Take note, this is not the final answer as you need to replace the theta back to x term. Notice that our original integral was in terms of x, so we have to leave the answer in terms of x as well. See that our earlier substitution was x equal to square root 5 tangent theta. We know that tangent is equal to opposite over adjacent. By representing this in right angle triangle, the adjacent is equal to square root 5 and the opposite is equal to x. From theorem Pythagoras, adjacent square plus opposite square, the answer is equal to hypotenuse square, or a square plus b square equal to c square. Therefore, the hypotenuse for this triangle is given by square root of x square plus 5. We know that cos theta is equal to adjacent over hypotenuse. Therefore, from this triangle, cos theta is given by square root 5 over square root of x square plus 5. As secant is equal to 1 over cos theta, therefore secant theta is equal to square root of x square plus 5 over square root 5. Substitute this info accordingly into the answer that you have obtained just now and simplify. You should be able to get the following answer. Now refer to example 11b. As the expression inside the square root is a square minus x square, we should apply the trigonometric substitution x equal to a sine theta. Here a square is equal to 5, therefore a is equal to square root 5. Differentiate x equal to square root 5 sine theta, you should get the answer is square root 5 cos theta. Substitute both x and its derivative into the given integral. Simplify, you should get a new integral in terms of theta only. Next, expand the expression with the power and factorize the expression inside the square root. Then, apply the relevant identity. 1 minus sine square theta is equal to cos square theta. Simplify the integral. You should get 5 integrate sine square theta d theta. To integrate sine square theta, you need to apply the formula for sine theta to the power of n. You should get the following answer. Take note, this is not the final answer because you need to replace theta back to x. See that our earlier substitution was x equal to square root 5 sine theta. We know that sine is equal to opposite over hypotenuse. Representing this in right angle triangle, opposite is equal to x and hypotenuse is square root 5. From theorem Pythagoras, the adjacent is given by the square root of 5 minus x squared. In addition, cos theta, which is equal to adjacent over the hypotenuse, is given by square root of 5 minus x squared over square root 5. Isolating for theta gives the answer for theta is equal to the arcsine of x over square root 5. Substitute the information accordingly into the answer and simplify. You should be able to obtain the following answer in terms of x. Let's proceed with example 11c. As the expression inside the square root is x squared minus a squared, we should apply the Trigo substitution x equal to a secant theta. Here, a squared is equal to 16, therefore a is equal to 4. Differentiate x equal to 4 secant theta, the answer is 4 secant theta tangent theta. Substitute both x and its derivative into the given integral and simplify. You should get a new integral in terms of theta only. Next, expand the expression with the power and factorize the expression inside the square root. Then, apply the relevant identity. Here, secant squared theta minus 1 is equal to tangent squared theta. Simplify the integral, you should get the integration of 1 over 16 secant theta d theta. 1 over secant is equal to cos theta. Therefore, the integration can be simplified to 1 over 16 integrate cos theta d theta, which is equal to 1 over 16 sin theta plus c. See that our earlier substitution was x equal to 4 secant theta, in which secant theta is equal to x over 4. Thus, cos theta is given by 4 over x. We know that cos is equal to adjacent over hypotenuse. Representing this in right angle triangle, adjacent is equal to 4 and hypotenuse is x. From theorem Pythagoras, opposite is given by the square root of x squared minus 16. In addition, sin theta is equal to square root of x squared minus 16 over x. Substitute this into the answer and simplify, you should be able to get the following final answer. Refer to all the three answers that we have obtained, for example A, B, and C. Take note that when you apply theorem Pythagoras, you should obtain the answer for the side equal to the original square root as given in the question. If the square root that you obtain are different with the one given in the question, that means something wrong with your answer, which you need to double check. In summary, following is the trigonometric substitution table that could guide you in using the trigonometric substitution. In order to get better understanding on trigonometric substitution, please do exercise 1.4. In the next lesson, you will learn on how to integrate the rational function. So,